Okay, so number 3, first thing we're going to do is we're going to verify that I cross I, J cross J, and K cross K are the 0 vector. So first thing we're going to do, the I vector, of course, is written 1, 0, 0. Okay, so if I was going to write it in a determinant form to figure out what the cross product is, I would write it out like that. And you could see that, you know, for the when you figure out the I component, you're just left with zeros to make the determinant. So the determinant is going to be 0, right? And then when you find the J component, you're going to have 1 times 0 and 0 times 1 to form your determinant. You're also going to get 0, right? And then the K component, same thing's going to happen. 1 times 0 minus 0 times 1. So you're going to get 0 for all your components. So basically, if you have the I vector times itself, you are going to get you're going to get the 0 vector as a result. And same thing with J and K, because the only difference with J and K is instead of having the 1 there, you're just going to have the 1 here for the J vector. You're going to get the same result, which is the 0 vector. Okay, so you're always going to get the 0 vector for I cross I, J cross J, or K cross K. And it turns out if you ever take any vector and cross it with itself, you are going to get the 0 vector. And we'll see why in the next couple pages, okay? Next step, we are going to find I cross J, okay? So let's find I cross J. I cross J would be I, which is 1, 0, 0, cross J, which is 0, 1, 0, okay? Now, when you do this one, you might have some determinants which are not 0, so let's try to find the first one. The I component, this determinant would be 0, right? So the I component is 0. So we're doing B right now. So this would be BI, part I. And the I component would be 0, right? And then let's find the J component. The J component would be 0 also. And then finally the K component would be 1 times 1 minus 0 times 0, and that would be 1. Okay, so actually I cross J does give you a non-zero vector. It gives you actually the K vector. Okay, so this turns out to be the K vector. Okay, what about J cross I? So J cross I would be, on the top you would put the J vector, which is 0, 1, 0, and the second vector would be the I vector, which is 1, 0, 0, and you're saying, well, that looks the same. It's actually going to turn out to be very similar to the first result. First we're going to cover up this vector, and we're going to get a determinant of 0, so the I component here is 0. Then we're going to cover up this column, and we're going to take the determinant here, and it's also going to be 0. And then finally, we're going to cover up the K column, and then this determinant is going to be 0 times 0 minus 1 times 1, so it's negative 1, right? So here, we're kind of getting like the opposite vector from when we got before. And so this is actually the negative K unit vector as the answer. Okay, and so let's do now J cross K. J cross K would be, J is 0, 1, 0, of course. K is 0, 0, 1. Okay, and if we cover that one up, we can see that we're going to get a determinant of 1, and so that would be 1. And then if we cover the J vector up, we are going to get a determinant of 0. And if we cover the K vector up, we're going to get a determinant also of 0. So that is the answer for B2 J cross K. So J cross K would give an answer of the I vector. Okay? And then what about K cross J? So K cross J would be 0, 0, 1, which which would be k, and j would be 0, 1, 0. So now I'm going to cover up I, and I'll get, let's see, this would be 0 minus 1 times 1, which would be negative 1. So we get negative 1 for the I component. And then we're going to cover up the j vector, and we're going to get 0. And then we're going to cover up the k vector, and we're going to get 0. Okay, so for k cross j, the result is the negative I unit vector. What about I cross k? So I cross k would be I cross k, and first I'm going to cover up the I column, and the determinant is going to be 0. This would be B3, B0. And then I'm going to cover up the j vector, and the determinant here is 1 times 1 minus 0 times 0. And remember, it's the middle element is going to get a negative sign. So even though it's positive 1, you're going to make that negative. So it's going to be negative 1. And then when we cover up the k vector, we're going to end up with a 0 determinant again. So it's going to be 0, negative 1, 0. So that would be, the result is the negative j unit vector. And last of all, we're going to do k times I, which would just be k cross I. Okay, and in this one, when we cover up this one, we get 0 again. When we cover up j, then we get 0 times 0 minus 1 times 1, which is negative 1, but then we take the negative of it because it's the middle element. And so that'll be positive, and the last one will be 0, of course. And that would give us the positive j unit vector for that one. Okay? So it says comment under results. Well, you can always see that, like, if you cross I and j together, you get the opposite, the remaining vector k. If you cross j and k together, you get the remaining vector I. If you cross I and k together, you get the remaining vector j. Okay? The only thing different is like, depending on which order you take them in, you're going to get a positive k vector or negative k vector, positive I vector, negative I vector, etc. So it's just going to change the direction if you reverse the direction. Which way is going to be positive, which way is going to be negative? Well, we're going to find out more about that in the next section. Okay? So for number 5, our final objective is to find the A dot B cross C result, but of course the first part, which is in parentheses, is B cross C, so we're going to do that first. So B cross C would be the determinant of this matrix, right? I just wrote the B vector across the middle, 2, negative 1, 1. I wrote the C vector across the bottom, 0, 1, negative 2. And then I'm going to find the determinant of this matrix. So the I component is going to be negative 1 times negative 2, which is positive 2, minus 1. So it would be 1 I. And then the j component would be 2 times negative 2, which is negative 4, minus 0. So, and you can take the negative of that because the middle one is going to be minus. So it'll be positive 2j. The k component would be 2 times 1, which is 2, minus 0, which would be plus 2k. Okay? And so that would be the result for A. And then to find B, we would take the dot product of 1, 3, 2 and 1, 4, 2. Now that you're doing cross products, the dot product is easy, right? It would be equal to 1 times 1, which is 1, plus 3 times 4, which is 12, plus 2 times 2, which is 4. And the answer is 17. If you remember, this is called the scalar triple product. Okay, now let's do the last one on this page, 7. prove that A cross B plus C is equal to A cross B plus A cross C using these component vector forms. Okay, so first we're going to do this one. So this is equal to A cross, and B plus C would be B1 plus C1, B2 plus C2, and B3 plus C3, right? And on the right side we'd have this mess, okay? And there's a couple ways to do this. One is you could go through the determinant method that we've been doing, but for when you have variables, that's pretty tedious, okay? Now here's a snapshot of what you can find in the formula sheet, okay? So the formula sheet kind of summarizes the result of the cross product using the components pretty neatly here. Basically the pattern is 2, 3, 3, 2, 3, 1, 1, 3, 1, 2, 2, 1, okay? So I've rewritten the A cross B using this notation. Instead of B and W, I used A and B. And for A cross C, what I did was I substituted A and C in for V and W. Okay, so you can see that these two look very similar, but instead of the B's here, I have C's here. Okay, and now what I'm going to do is I'm going to add these together, and then I'm going to do a cross product of these again using this formula. So I'm going to go offline here and do that and come back. Okay, so let me tell you what I did while I was gone. So first of all, I used this formula here and substituted A in for V, and instead of the W's, I put in these terrible expressions here. So you can see that I have A2 times the third element of this one. I have A3 times the second element of this one, etc. I followed this pattern here. 2, 3, 3, 2, 3, 1, 1, 3, 2, 3, 3, 2, 3, 1, 1, 3. See, I followed this pattern and I just did the cross product between A1, A2, A3 and this terrible mess. Okay? And then on this side, all I did was I combined, or I just kind of put them in a different order. I put this one first, this one second, this one third, and this one fourth. So this was like, this one is this one, this one is this one, this one is this one, this one is this one. Why did I do that? I put the pluses together, I put the minuses together, and then you can see, if you look across the equal sign here, that this term here, A2 times the quantity B3 plus C3, is equal to A2B3 plus A2C3. Okay? So by arranging it in this way, I am already showing that these two are equal via like distributive property. Okay? So we've gotten to the end already. All right? And that's it for this video.